Isaac Newton said that the amount of gravitational pull is proportional to the amount of mass in the object. Light does not have mass and should not be affected by gravity, but has been observed to curve around gravitational fields. How is this possible?
I'm Nishant Sisla, and I want to talk today about the relationship between light and gravity.
Light is a part of the electromagnetic spectrum, a range of waves that come in different frequencies and are considered to be massless, or weightless. This phenomenon of light appearing to bend is explained by Einstein's theory of general relativity. We see gravity as a force that attracts one thing to another and causes things to orbit around a central point. However, general relativity says that instead of objects moving along curves in a flat space-time, they travel along straight lines in a curved space-time. These straight lines, or geodesics in space-time, are caused by objects exerting a gravitational pull. Light travels along geodesics, and so paths of light are curved by gravitational force, despite not having any mass. This means that when light travels past a large object, the geodesic curves, and it appears that the light does too. In 1919, this was proved by Sir Arthur Eddington during a full solar eclipse. The Sun is the largest object in our solar system, and it exerts the greatest amount of gravitational pull. Therefore, the ideal place to test Einstein's theory would be near the edge of the Sun. The eclipse reduced the glare from the Sun enough to allow observations to take place. Using telescopes and comparing what he saw with what he knew of the star's location, Eddington measured light being deflected by the warped space-time. It was a minuscule amount, but it was enough to prove Einstein's theory was correct. Recently, Einstein's theory of general relativity was proved to be true for objects as big as galaxies. It can be used to spot galaxies that are blocked from sight by other galaxies. Based on the curved geodesics coming from that blocked galaxy, the details can be inferred. This is called gravitational lensing because a galaxy is basically acting like a lens in a cosmic telescope. So even though light is massless and immune to gravity, the paths it travels on are affected by gravity, and that is why light appears to be affected by gravity.
In fact, light can sometimes behave in the same manner as gravity. The self-gravitation of light theory states that light could curve space-time. The equations of general relativity imply that the space-time curvature created by light moving should influence the movement of the light itself, because an electromagnetic wave has a non-zero energy momentum vector and should therefore curve space-time like gravity. How does it do that? That remains for scientists like me and you to figure out.